So, okay. Let's talk about this logarithm. See, we say log of 1000 to the base 10 is equal to 3. You should do it this way. Say 10 to the power of 3 is equal to 1000. And how about this one? This one, base to the power of this one is equal to, this is going to be 16. You know, 10 to the power of 3, it means 10 times 10 times 10 times 10 is equal to 1000. So what we do, the base of this one is going to be raise it to the power of this number or whatever it is here, and it's going to be, the result is going to be 16. So let's just say one way to find out, you know, what is going to be. Sometimes they ask you what is x. What is the exponent? It's going to be the exponent of this number. 2 to the power of 6 is going to be 16. We could do this way to find x. So it's equal to 4. 2 to the power of 4 equal 2 to the power of 4 is equal to 16. Okay? And this one, 2. See, 8 has to be raised to the power of something. 8 to the power of x is equal to 2. Why? How do we solve? There is one way to solve it. That we say 8. It means 2 to the power of 3. See, 2 to the power of 3 is equal to 2 times 2. 2 times 2 is going to be 8. 2 times 2 is going to be 4. 4 times 2 is going to be 8. So 2 to the power of 3, we can, you know, break it down. You know, it's going to be 3 times multiplied by the number of the exponents shows that how many times the base is going to be multiplied by itself. As we say, it's like this. So we say 8 to the power of x, this is 8, okay, this is 8. Is going to be equal to 2. So we can say 2 to the power of, see, in radical, you know, if we raise a number to the power of, this one has exponent 3, and we raise it to the power of x. So this is going to be multiplied by this. It means 2, the exponent is going to be 3x, and then is equal to, we can, actually the exponent of this one is going to be 1. Okay, so the base are equal, so 3x is equal to, 3x is equal to, it's going to be equal to 1, okay, and x is going to be 1 over 3. So the answer is 1 over 3. So we say if 8 is to the power of 1 over 3, 1/3 is going to be 2. Okay, here let me mention something here. As we talked about it earlier, 8 to the power of, the exponent is fraction. It's fraction that you see that this is exactly equal to cubic root of 8. We can write it this way. So we say the exponent of 8 is 1. We can write, say, 8 to the power of 1/3. Okay. Let's say it's something else. 2 to the power of 4/5. You know that 2 had the exponent of 4 and fifth root of this. We can write this way, you know. We can write this one. Converted to with radicals, that's what it means, you know. 2 to the power of 4, 5. That's what it means. Okay, let's talk about a couple of examples. Log. This is, see, this was the base 10. This is the base 2. This is base 8. So anything. But usually we don't write it. When the base is 10, we don't write it. And you use the calculator to find out that what's going to be the result of this one. Here we turn it on and then clear. We say log. This log here next to 7. You push this one log. This is the base 10. Say 1000. We can close the parentheses and then we say it's 3. So actually the base is 10. Usually we don't write it. When the base is 10, we don't write it. But other than that, if the base is 9, we write it 9. I ask you a question. What is going to be this one? What is going to be this? Okay, I want you to know. I want you to tell me that what is going to be here. Log of what to the base of 9 is equal to 2. So it was easy. So we say 9 to the power of 2, 9 to the power of 2, as we did here. 2 to the power of 4 is going to be 16. 8 to the power of 1/3 is going to be, it means actually, I said, you could it like this. Is it going to be 2? Actually, what's going to happen, you know, we can write 8 as 2 to the power of 3, and 3 cancels out, and it's going to be 2. Okay. Now, this question, what is going to be the result of this? Because if we raise the base to the power of the one here, the number here, see, after the equality, this side of the equality is 2. Okay, 9 to the power of 3 is going to be 81. 9 times 9 is going to be 81. So the answer here is going to be 81. 9 to the power of 2 is going to be 81. So there are many examples, you know. Let's, because we have to go a lot of other subjects. So when I mean, you know, this is very important. When you want to draw the when you want to draw the logarithm function, you know, you want to graph them. We will talk about it later. But if you want to learn how to graph those by hand, not by a calculator, you got to use your hand to find out the thing. Okay, so we talk about what is log 1/25 over 125 base 5 is equal to what? See, you learn that this is 5 times 5 times 3 times 5 times is equal to 125. Okay, so you know that this is has a 5 to the power of 3. So actually it's going to be 5 over 1 over 5 to the power of 3. 125. Okay. So actually what here is going to be this one. See, we said earlier that if you have something like a, b, I don't know, a, b, c to the power of 3, we can write it this way. A, b, c to the power of -3. Any number. This could be, these are variables, it could be any number. I'm just giving you an example. So actually what happened if we have 5 to the power of -3 is equal to 5 over 5 over 3. So this is going to be 1 over 25. See, what you do, you write it as a, this is equal to 5 over to 5 to the power of -3. So what you do, you just write the 5 over 3, you invert it, you say 5 to the power of 3 is equal to this, and this is equal to that, 5 to the power of -3, we can write it that way. So it's going to be -3. I'll give you another example. Let's now do the other way around. We have exponentials, and we are going to convert it to logarithm. Exponential number. It's a 3 to the power of 5. What is going to be? 3 times 3 times 9. Let's see, a little bit lower, so the exponent, the smaller one, like 3. Means 3 times 3 is going to 9 times 3, 27. It's going to be 27. Okay, write it in a logarithm way. We change it to logarithm in terms of logarithm. So what we say is log of. See, this was the base, and this is the exponent there, and 27 is going to be logarithm of 27 to the base of 3. Is going to be 3. 3 to the power of 3 is going to be 27. We write it here, the answer here. This is just the opposite of this, when you want to express it in terms of exponents, in terms of exponent, you do this. Okay, 4 to the power of 3. You know that 4 to the power of 3 is 4 times 4 times 4, 16 times 4, 64. is going to be 64. You can use the calculator. You know, in examination, you go to university, almost, you know, all university lets you to use calculator. So it's very, it's going to be easy. The mathematics is going to be easy. Okay, now we have this one. We want to write it in terms of logarithm. What we say? 4 to the power of 3 is equal to 64. Log of base 4 log 64 with base 4 is equal to 3. It means 4 to the power of 3 is going to be 64. Okay, that's too much for that. You know, let's talk about some other things in logarithm. If you want to expand expanded logarithm expression, so we have log of a to the power of 2 x. Let's use this variable is better. Y to the power of 2 x 3 z x3z, like no power. Do you know you can write this? You can write this. This is division. You can write this like this: log, okay, y squared minus. See, this is division minus log x to the power of 3 z. You're trying to expand it. So this is multiplication. Okay, this is multiplication. X 3 times x. We can write this one as a summation of these, like this. This is going to be like y squared minus, and then you have the parentheses here. You have the parentheses here because this we are going to change it. We can change this one like this: log x3 plus log z. See, we don't write it's going to be base 10. When we don't write the base, it's going to be base 10. So the result is going to be, see, the minus, this is actually minus 1. We multiply by this, by both 2. So the result is going to be log y to the power of 2 minus log minus this. It was plus this one, right? And just minus multiply by another number that's positive is going to be minus log x to the power of 3, and then minus again to the power of, just don't multiply this one by this one and leave this one alone. You have to multiply minus 1 here by this one. It's going to be minus like z. Okay, and there is another property that this logarithm has. Okay, this is so far expanded. We can write this one as 2 log y minus 3. 3 is going to be, the exponent is going to be come behind this and say log x. We can write it like this, and minus log z. That's the last step for expanding the these logarithm functions, expressions. Let's the same example. Let's get back to this, and we can write this one original situation. We can say log y squared minus 3 minus log x to the power 3 minus log z. See, if we factor out minus 1, minus from this is going to be log minus log x3 plus log z. Okay. We are going to get back to this. So this is now. No, I gave you a little complicated. Otherwise, so you can write this. Think about this. See, this is there is an addition between these two. We can write it in a multiplication form. We say log x3 plus log z is equal to log x3z. Okay? So we write this one. It's going to be log y squared minus log x3z. And so it's now we can change to division. This is minus between those. It's going to be changed to division, which is equal to log is the y squared is going to be log x3z. These are multiplication. See, the x3 is multiplied by. Actually, we don't write it. When we write the variable, usually we don't write, say, 2x. We don't write 2 times x. It's just 2x is equal to 2 is multiplied by 2 by x. Or here x and y. It's x multiplied y by 1. Okay. So this is one things that you should know about logarithm. Let's see just a couple of examples. Log 5 plus log 6 is going to be, see, we can write it as log 5 times 6 is going to be log 30. If you use calculator, it's going to be, you're going to get the same answer. We turn this on, clear. You say log 5, what's going to be? It's going to be 0.69. We write up to 3 decimal places. 699. We write it up to, we round it to up 3 decimal places. And this is plus log of 6 is going to be, see here, say log 6, log of 6, these are power of 10, means 10 to the power of something is going to be 6. This one, 10 to the power of 0.699 is going to be 5. Close to 5 because I didn't write it. It's going to be 5. So log of 6 is going to be 0.778. Now find log of 30. Log 30. Is it correct? This is 1.477. See, log of 30 is equivalent to this one. The same if you have log 5 minus log 6, it's going to be log 5 over 6, you know. And you can find it. So let's add this together to see if it's, we find this one from calculator. So, okay, let me show you here something else. If here you want to write the value of this one here at the last, it's going to be your last line. You go there, up there, and enter, and you write it. You bring down all this here. Plus what? Logarithm of 1 logarithm of 6 is going to be this, and then you push enter. It's going to be put, and then you add. It's 1.477. So if you add this together, it's going to be 1.477. Okay. Yeah. Okay. So, you know, we talk about natural logarithm. Natural logarithm, like natural logarithm of 5, what is that mean? Mean actually natural logarithm, the base, we don't write it, is e. E to the power of x is going to be 5. What is going to be? E is equal to 2.7 something. Okay, we talk about this later. 2.718. You know, here is here. Second, this is 2.718. Okay, that's enough for this video. And see, these are the very basic things that you should know before you go to college. You should look at these videos and you know, get ready.